third topic of today is then trading, trading sizes, right? Now, so what we have seen so far was that, well, shorting was quite easy in terms of the Markovich model. You could just remove the positivity constraint. Risk-free borrowing, you just introduce this V minus, and then you add it into the constraint, making sure that the sum of what you're buying minus what you borrow is 1, is 100% of your money, and then add it in the objective function properly. Now the third thing is another useful practical constraint in real life, is that in many cases we want to minimize the number of assets in our portfolio. So if you were a portfolio manager in a pension fund, in many cases you will have to deal with portfolios of assets, universe of assets as big as thousands of or tens of thousands of asset classes, and you want to make sure that you don't want to work with all these assets. You have to limit them, and sometimes you have to limit them in a hard way, saying that, well, I'm not allowed to have more than 50 assets in this portfolio. So the question is, how do we add that, right? So it's a kind of a simple practical constraint, but it could come quite handy. How do I limit the number of assets in my portfolio? And that could be due to transaction costs, obviously. One thing is the more assets you have in your portfolio, the more it's going to cost you. The smaller the individual amounts become, also if there are fixed costs, let's say. The other more important maybe is the monitoring requirements. So again, as a portfolio manager, you need to have an idea of what you're investing in, right? So you need to have people who know everything about the underlying assets. You can't just say, well, I mean, these are just some assets I found from the internet, right? So you have to study them. You have to read their if there's some white papers explaining what these papers are about, you have to do your own analysis, risk management, and so on the individual papers. And that kind of monitoring is quite expensive. So that's maybe the main reason why you want to, as a portfolio manager, you want to keep the number of assets you're working with down. There are different ways of doing it. Now we just get into, if you were to use an optimization model and you want to reduce the number of assets, how you would do it. Right. So here is how this is done. And let's walk through this slowly. And notice here that the first thing which we're introducing, which is new here, is a binary variable. Because now we want to limit the number of assets in our portfolio. We need to have a way of counting how many assets are actually chosen in the portfolio, right? So we have a binary variable I call zi, where the solver, when it's solving the model, has to put a value of 1 if that asset I is included in the model, and the value has to be 0 otherwise. So it's a counter. The binary variable z is counting if an asset is in the portfolio or not. And what we want, then we want to put a limit on the sum of z's. So we say sum over all the z's, that is 1 or 0, depending on whether the asset is in the portfolio or not, has to be less equal kappa, kappa being a parameter saying this is the maximum number of assets allowed in our portfolio, right? So if my kappa was 10, let's say, then sum of z's less than 10 would be I don't want more than 10 assets in my portfolio, right? So that's all fine, but how do I make sure then in the model that z would be put to 0 or 1, depending on whether the asset is in the portfolio or not? That's happening down here. Essentially, let's start by, it happens on the right-hand side of this equation. So if you have x less equal x bar times z, and let's just start by saying that x bar is equal 1, right? So we allow the individual assets, we allow the portfolio to be made up of just one asset. 100% can go into one asset. So what does it say? It says then that if this number is positive, so if x is chosen in the portfolio, x, remember, that was the weight on the given asset in the portfolio. So if x is greater than 0, that means I'm investing in that asset, right? So if x was positive, I write it maybe over here so it becomes easier to see. And remember, sum of x is 1. So if xi, that's less equal zi, and z could be only 0 or 1. Now, if x is 0.2, let's say, has to be less than, it could be 0 or 1. What should z then be in order for this to be true? 1, right? It can't be 0 because 0.2 is not less equal 0. So the second that your solver decides that we want to invest a little bit of money in the asset I, some positive value, then z has to be 1, otherwise that equation is not valid, right? So that's very simple algebra. That's the logic of how you make sure you tell the solver that you want it to set z equal 1 if asset I is chosen in the portfolio. That's simply how it works. You tell the solver by the way of this simple inequality that this should happen, has to be set to 1. Now, if x was 0, then 0 could be less equal 0 or 1, right? Could be any of the two. But then you would normally say, well, then what would it choose? Would the solver choose to put z to 0 in that case, or to 1? Anybody can think of what would the solver normally prefer to do? Yeah.
I don't know if it prefers, but it makes sense to put it to 0.
Yeah, because it's kind of yeah, exactly. So your answer is you don't have a guarantee, but we can be almost sure that it would put it into 0. Normally, because if it puts it to 1, it's going to either cost something, or it's a resource that we don't, it's a limited resource, right? In this case, if we have the kappa being 10, then z becomes all of a sudden a limited resource. Number of assets. You want to have more assets in your portfolio for whatever reason. It can become a limited resource. Then it would prefer to put it into 0. But it could be also cases where it would be 0 or 1. If it's not a limited resource, it could be both. So you can't be guaranteed, but in many cases, then you have to look at the rest of the model and find out what you would choose in that case. But what is important is that when you're modeling in this way, you want to make sure that in the direction where you want to have your control, you have to make sure that it is there is no doubt what the solver should do. So what we want to make sure is, in this case, that whenever we're investing in something, then z has to be 1. If it's not investing, then it could be 0 or 1, and then it might choose to, depending on whether it costs something or not, it put it to any of them. But in this way, we make sure that it's not higher than certain number anyway, because if the limitation we are putting is that we don't want kappa to be greater than 10, then it's important that this one is always binding, and that's the case, right? So this will be positive. So we know that it's definitely not more than 10. It could be less than 10. We don't care. As far as it's less than 10, then we are okay. And that's why this equation is the important one. The other is less important. But in most cases, it will take care of it, because automatically we put it to the opposite, because otherwise it costs. It's a limited resource, right? And there are some extras in there as well. So notice what happens with if you take both the left-hand side and the right-hand side. So let's say let's start with this one. Let's say this was 0.2 and 1 here. Now let's take another example. Let's say it could also be 0.0001. Still is less equal 1, right? So that is like 1% of a percent, right? It's a very small amount. But as soon as I have something in my x, then the value of z has to be 1. But it could be that I have a limit saying that my x bar, x under bar, that's less equal that amount, right? So the right-hand side is correct. But let's say, what do I put in there? So let's say if I put in the value of x on the bar, I put the value 0.2, right? And z would be now 1, because the right-hand side is 1, right? So I get this one multiplied by 1, less equal. Does that hold? No, right? So what is the effect of this left-hand side then? The left-hand side then says, so this one is not true. So the effect of the left-hand side is that it says you don't have to pick up that asset in your portfolio. But if you do, then you have to buy at least 20% of it. Because this one would be then correct, right? So if it was 0.2 times 1, 0.2 here, this is correct, right? So either do that, or don't do anything at all, or have the 0 on the both side, right? So it's an either or. So either buy at least 20%, or don't buy at all. It doesn't say that you have to buy 20% always. It says if you buy, then you have to buy at least 20%. So that's the effect of the left-hand side. And the right-hand side, we already had this, but you can also have a limit on that. So let's say if you're here on the right-hand side, so I say, well, 0.99 is less than 1. But then you can have a limit saying that my xi has to be less equal, and xi bar. And if that was 0.5, so I never want an individual asset to be more than 50% of my portfolio, let's say, then again, this guy is not correct. Then it says, well, then you have to go up to that limit and not more than that, right? So that's just limiting. You're not allowed to have more than a certain amount in a given asset, right? So these are the size constraints, and you have an assignment to work with that today as well. So these are, by the way, kind of warm-up exercises for you to get your hands on GAMS. There is a helping file I gave you. It's called the divcon.gms. I think that's something to that effect. So that would be like you're starting, and then there's an assignment 2, where you have to start working with this. And I think assignment 3, some of it is for today, and some of it is for next week. So you can get started in the assignment 2. Right, and any questions in regards to size constraints?
Can you repeat the sentence with, if you buy, you have to buy 20% what?
Right, so in this case, I can maybe write it up. So that was the effect of a constraint like this one. Yeah. So this one, this left-hand side here, it tells you you don't have to buy, so it says, you don't have to buy a given asset, but if you buy at least x underbar %, right? So that's what's the effect of this left-hand side. Yes?
Can you set the lower bound to negative to allow shorting, or is that a bad practice to do with the model?
Well, you could do that, actually. Yes, there shouldn't be. I mean, it's not a bad practice. It's you just have to know what you're doing. But yes, you could do that. Yeah. So that's actually the reason why I brought the example of shorting. I mean, I start the plain vanilla. I could have started the plain vanilla Markovich by allowing shorting, but actually I consider, if you have shorting allowed in the model, then from a financial point of view, it's not so much plain vanilla. It's actually pretty dangerous. So that's why I started with, say, plain vanilla Markovich. Shorting is not allowed. Then, well, if you want to start playing with shorting, then you have to remove that constraint, or you have to relax it, but then you have to limit it in one way or the other. So that would actually be a combination of shorting and size constraints is actually quite, it could be a good idea. Other questions regards to size constraints or shorting, leveraging? Right?